Welcome back to Paideia Classes. In this video, we are continuing with part 2 of our exercise 1.3 adventure. If you have not watched part 1 yet, I recommend watching that first to get a solid understanding of the initial concepts. So today we will be solving the remaining questions and further deepening our knowledge of subsets. So let's get started. Let's solve the third question. We have given a set A whose elements are 1, 2, set 3, 4 and 5. Now we need to tell which of the following statements are incorrect and why. Okay, let's see the first statement. The first statement is that 3, 4 is a subset of. So 3, 4 will be a subset of A if all the elements of this set are also the element of this set. So this means what are the requirements for this statement to be true? That 3 belongs to A and 4 belongs to A, which is not the case here. The set 3, 4 belongs to set A, not 3 and 4 as an element. Therefore, this statement is incorrect. So, first is incorrect. Let's see the second option. 3, 4 belongs to A. Now, of course, this set 3, 4 belongs to A as an element. And therefore, this statement is correct. So, we should not choose this. And then the third option is, what is the third option? The third option says that set 3, 4 is a subset of A. Okay. Again, what is the definition of subset? It is that every element of the set should belongs to here. So, what is the element of this set? The element of this set is what? 3, 4, right? The element of this set is 3, 4. 3, 4 belongs here. Not 3, 4, the set 3, 4. And 3, 4 also belongs to A. So, therefore, every element of this set is A, the element of A. And therefore, this statement is correct. This is incorrect. So, we will not choose the third option also. Now, let's see the fourth option. Fourth option is 1 belongs to A. Does 1 belongs to A? Yes. And therefore, this statement is also correct. Fourth is also correct. This is wrong. These three are correct. 1 is a subset of A. 1 is a subset of A. 1 is not a set. It is an element. So, something can be a subset of a set if and only if it is a set. So, this is not even a set. So, yes, this statement is incorrect. 1 is an element. So, of course, 1 belongs to A. But 1 is not a subset of A. So, therefore, this statement is correct. So, we have the first option which was incorrect, and then we got the fifth option which was incorrect. Okay, let's see this. Set 1, 2, 5 is a subset of A. Let's write the subset A. 1, 2, set 3, 4 and 5. We can see that all the element of this set is also the element of this set, and therefore this statement is set 1 to 5 belongs to A. Now, set 1 to 5 is a subset of this set. Is a subset of A, but it does not belongs to A as a set. So, therefore, this statement is wrong. 1, 2, 3 is a subset of A. Now, 3 belongs to 1, 2, 3, but 3 does not belongs to A, and therefore this statement is incorrect. So till now we have got option 1, option 5th, and then option 7. And I am telling you the reason. And also option 8. Let's see the next option. Phi belongs to A. When we are saying phi belongs to A, what is phi? Phi is an empty set, right? So phi, no doubt that phi is a subset of A. But phi does not belong to A as an element. If it would have belonged to A, it would be present like this, 1 or something. Phi would have been present in A. So phi does not belong to A. It is a subset of A, and therefore your 9th option is also incorrect. Let's see the 10th option. So yes, empty set is a subset of every set, and therefore it is also a subset of A, and therefore this statement is true. Set phi is a subset of A. This will be true if phi belongs to A, which is not the case as we have already discussed in option 9, and therefore this statement is also incorrect. So these are the options that are incorrect. These are the statements that were incorrect. Okay, let's see the next question. Write down all the subsets of the following. So there used to be a topic power set of a set which is not in your new edition. But we still can write all the subsets of the set because we know the definition of subsets. So first we need to write all the subsets of this set. Now, whenever you are writing all the subset of any set, the first set that you should include should be phi. And then we will make a pair. And we'll see in the other options. So here we have only one element A. So A is also a subset of A, and this is also the whole set. So there is only two options, phi and A, and both are subsets of A. Let's see the second option. Then this will be A, B. First thing that we should always write whenever you are writing all the possible subsets of any set, the first subset you should write is that is a subset of all the sets. Then this set A would be subset of AB because all the elements of this set is also the element of this set. And similarly, the set B would be the subset of B. And the last set that you should write should be always the whole set. Okay, so first we will make pair of 1, 1, and then 2, 2, and then 3, 3, whatever number of elements we have. So there are only 2 elements. So we have first the MC set, which does not contain any element. Then we write the sets with 1 element, and then we write the sets with 2 elements, which is all we have in this set. Okay, let's write the next part. The set 1, 2, 3. Again, the first subset that you should list is always empty set. Okay, set with no element or 0. Then all the subsets with single element or 1 element. So 1, 2, 3. Then all the subsets with 2 elements. What are the possible pairs? 1, 2, 1, 3, 2, 3. You cannot make any other subset with 2 elements of this set. And then the set of 3 elements or the set of all elements. Okay. Let's see the next example. We need to write all the subset of this set phi or empties. Okay, so first subset should always be phi. which is all we have. There is no element to make subset with 1, 2 or 3 elements. There was 0 elements and we only have one subset of the empty set, which is empty set itself. Okay, let's see the next question. Write the following as intervals. Okay, so if you have seen my previous video, you can do this. The first part is x such that x belongs to R, and this and all the x should be less between -4 and 6, and we will include 6. Okay, let's draw this on number line. We have -4 and 6. Then all the elements between these two numbers, and since there is equal, less than and equal signs on 6, we would also include 6. So if we want to write this in interval form, this would be -4, and since the equal signs is on 6, and we would close this end. So this is semi-interval -4, 6, which is closed on 6. Let's see the next option. X such that x is a real number between -12 and -10, and this is open from both ends. So this would simply be -12 -10. The condition is that when you write it in the interval form AB, your A should be less than B. So you cannot write this -10 -12 because -10 is greater, right? So -12 -10, and there is no equal sign on either end. So this would be open to both ends. Let's see the third part. X is a real number such that it lies between 0 and 7, and it is closed from the end 0 and open from the end 7. Fourth part. X such that x is a real number and it lies between 3 and 4, and it is closed from both ends 3, 4. I have explains all the details of this in my previous video, understanding intervals as subsets of real numbers. So please go and watch that, and it will be very clear to you. And if you still have doubt, you can always ask in the comment section. Okay, let's see the next example. Write the following interval in set buildup. So I have explained this also in my previous video. So let's solve this. For the next question, we need to write the intervals in set buildup form. I have told you the method of this also in my previous video, but let's solve it here. So first we have this interval, -30. Okay, how would we write it? X belongs to R, meaning x is a real number such that x lies between -3 and 0. And if we have open side to both ends, we would not write less than or equal to sign. We will simply write less than sign. This is how you write it in set buildup. For the next part, we have close interval 6, 12. X is a real number such that x lies between 6 and 12. Now we have close sign to the 6th end, so we will write the sign as less than or equal to, and we also have close sign to 12, and so we will write it as less than or equal to 12. Let's see the third part. semi-open interval 6, 12, which is open to 6 but close to 12, is a set X is a real number such that again X lies between 6 and 12. Now X is open to the 6 side, so we will write less than sign, and it is close to the 12. Therefore, this sign should be less than or equal to 12. This means we are including 12. The next part, for the next part we have minus 23, 5. Again, X is a real number such that it lies between minus 23 and 5, and it is close to the minus 23, and therefore we need to include minus 23. So we would write less than or equal to sign, and it is open towards 5, therefore we will write less than 5. Let's see the next questions. What universal set or sets would you propose for each of the following? Set or sets means you can take same set for both of these two options, or you can, if possible, or you can take different sets. Okay, let's see the options first. The first is the set of right triangle, and the second is the set of isosceles triangle. Now, if we consider this set X is a triangle. Now, these two are a specific type of triangle, and this set is simply X such that X is a triangle. It could be of any type. So, of course, these two sets, let's name them A and B for easy talk. Obviously, A is a subset of U and B is also a subset of U. And therefore, U can work as a universal set for both of these two options. Universal set is not unique. You can make different universal set. Okay, let's move to the last questions of this exercise. Given the sets A is equal to 1, 3, 5, B is equal to 2, 4, is equal to 0, 2, 4, 6, 8. Which of the following may be considered as universal sets for all the three elements? Set or sets again, so there could be more than one right answer. Okay, so this means all the elements. What is universal set? Again, what is universal set? It contains all the elements under the consideration. So the universal set, if U is the universal set, it should contain 1, 3, 5, 2, 4, 6, 0, and then 2, 4, 6 you have already wrote, so 8. It should contain all these numbers. Okay. Now, here we have 0, 1, 2, 3, 4, 5, 6, but 8 is not here. So, this cannot work as universal set. 5 cannot work as universal set. It does not contain anything. And then we have this set 0. Okay, good, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, it has 1, 2, 3, 4, 5, 6, and 8 also. So, yes, this could work as universal set. As for the last option, 1, 2, 3, 4, 5, 6, 7, 8, it has everything except 0. But universal set should have everything. And since it does not contain 0, it cannot be a universal set for these three sets. And therefore, we only have one universal set U, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This is the universal set for all of these three sets. So this concludes our exercise 1.3 of your class 11, chapter 1. Hope this helped you how to work with subsets. There were some great questions. And if you found this video helpful, useful, don't forget to like, share, and subscribe to Paideia Classes for more helpful content. Also, feel free to drop any questions or comments below. I had loved to hear from you and see you in the next video. Happy studying.